Welcome to today's session for the Chainlink Bootcamp. It is great to have everyone here. Just give me a second as I get the speaker to come up on stage with me.
Hello, Astrid. Everything good?
How are you? Yeah, it's good. How about you?
Doing great, thanks.
It's so hot in London today, you won't believe.
Perhaps hotter than Brazil.
Oh, well, how hot is it in Brazil at the moment?
Well, 50 degrees Celsius. Just kidding. Today's quite cool here.
Lovely. Well, I don't know if there's that much for me to mention from my end, but I was wondering if you want to potentially get started.
Yeah, sure. Let's begin then. Thanks, Astrid, for the introduction. Hello, everyone. I see a lot of people here from last lessons. Okay, friendly, not faces, like friendly faces. Yes, I can't see your face in this application. I would love to see you laughing from all of my funny jokes, right? But we'll see how it goes. But let's just catch up on one thing. I saw lots of questions at the end of last lesson on VRF. If you didn't attend for VRF and you are new here, okay, bear with me for 2 or 3 minutes maximum. It's just that we had a lot of questions, and it's natural because, like, I presented you the problem and then presented you the solution and presented not with a throughout explanation how to do, but I threw you in the direction of the documentation, quite like it. And it's natural to have questions, okay? So I have two resources here for you. First of all, feel free to reach me on Telegram anytime if you want to ask questions on Discord as well. Don't know if you are into the Discord of Encode already. Should be there are great communications there. And we have this tool. Let me present my window here. Classic infinite mirror. Yes, let me solve that. We have this tool that is GitHub for the content of today's lesson that has those issues here, okay? So 0 issues. I could have people asking questions here, how to use this timestamp, how this is processed, okay? You can ask questions here if you want, okay? It is good because one student can see the question of the other. If you don't want to come here, you want something faster, feel free to reach me. I have this Telegram chat just for that, for you to ask questions for all the students, ask questions for me. We can do that in Discord as well, okay? Please keep the questions coming. If you have questions after today's lesson as well, feel free to reach me as well in any of those channels. I'll be more than happy to provide you with help. Or if you want to listen more bad jokes, you know that I have plenty of them. Okay, so last lesson we went to VRF. Let me send you the link for this repository here. Okay. So, see some good messages in the chat. Hello, people from Brazil. Hello, people from my last boot camps. So this is the material we are using for today's lesson, the same from last lesson, where we learn about the Chainlink VRF. We learned about the network, the decentralized Oracle network, how it works and how we can use it for giving randomness. And this is going to be a good base understanding for today, because other than randomness, we can use the same network to provide automation for us. Let's just skip all of that and start automations, okay? So let's begin from here today. Use this link into the bottom. If you still have questions about VRF, I just presented you 3 ways that you can reach me. Let's get those questions rolling, okay? For automations, the idea is the same. We're going to see a problem that cannot be solved just with blockchain, just with the things natively present in a blockchain, for example, in Ethereum blockchain. And then we're going to see how Chainlink solves that problem. Okay, let's start with a very simple, with a very simple explanation, with a very simple example, actually, from what we did last Friday. This script, this contract here of my token. Remember, we studied the problem of randomness with this throw coin and blah, blah, blah. We're going to do a very simple example here. That is a function. We can even do a modifier here, okay? that is paused, that is public, view, and returns Boolean, paused. And this paused is going to be a variable inside that smart contract. Okay, this bool paused is a variable here that it starts as false. I don't need to make it start as false like this. By default, when I don't assign a value, it is false already, remember? So is paused is going to return this. And make, just like last lesson, return directly without the named return parameter, okay? But I want to implement a logic like this. Instead of having a function to directly unpause, I want to have a function that is unpaused after, let's use play, right? Or release. After, and then I pass a number, uint 256 seconds. And I cannot use seconds. Okay. Timestamp. That is public, payable, no, non-payable actually. And I want to implement here, and this is the problem statement, I want to implement a function, a time function, like a cron job to make paused to be false. It starts as true. Suppose it is true. I want to make paused to be false. Sorry for that little mistake. Pause need to start true. I want to make pause to be false after timestamp seconds. Let's make this duration, right? After duration seconds. Do you know any possible way to make this cron job, to make this time in the future job work in blockchain? I send a transaction now that is going to cause a state change in the future. What is the command for doing one transaction now in the present for it to make a state change in the future and 1 hour from now or 10 hours from now? A transaction that is going to be included in a block now, today, in that minute, that is going to change the state of the blockchain in a future block. How to do that in smart contracts? Do anyone know a way to do this? I know there are all the designs, all the structures that can implement this kind of behavior, like a state machine. But what I want to know if I have any way to do a transaction be scheduled for the future. You could be thinking, okay, I can have a transaction that is going to be executed in the future. Yeah. The problem is, in the future, when I change this boolean from true to false, there is going to be a state change, right? The storage of the blockchain need to be updated in the future. Let's do one day, okay? We are on 6th of November. This transaction is going to make deposit become false in 7th of September. September, 6th of September. The transaction is going to make deposit be false on 7th of September. Okay. In tomorrow's time, this state change that is going to happen in the blockchain need to be paid, right? We cannot make a state change happen in the blockchain without paying. If I make a transaction today, is there any way for me to pay for that future transaction that's going to happen tomorrow, for that future state change in today's transaction? There is no way to do that. Okay, we could implement all the techniques. Yes, Roger. For example, we could make a timestamp count, something like this. But I'm speaking about doing one transaction that triggers the other in the future. It's not possible to do natively inside the blockchain. This is the main statement here. It's not the full problem statement yet, because you might have realized that there are other ways to implement this functionality, but this is the beginning. The realization that there is no cron job in blockchain. There is no way to schedule, at least in Ethereum and Ethereum similar blockchains, there is no way to schedule a transaction to be executed in the future. So we could set an alarm for 24 hours and do that manually in the later on. That is correct. This is what Chainlink automation solves. Okay. Okay. These are to be called keepers, now called automations. Okay. That is the first realization, that there is no cron job, there is no scheduled tasks inside the blockchain. Every state change needs to happen from the beginning to an end of a transaction. After the transaction finishes, I cannot do any other state changes pertaining to that transaction because the gas was already paid. I have refunded any leftover gas, so there is no cron job, no scheduled tasks in blockchain. Okay. There are a lot of messages here in the chat. If you want to separate a question, set aside the question. There is another pane here, but I guess I can keep up with the message here. Astrid, if I miss anything, please feel free to interrupt me with the message here in the chat, okay? Sometimes they pile up quickly, so need to be quick here. So this is one thing when we want to make a logic to be triggered in the future. And also there are other procedures that we want to make in a smart contract that are like housekeeping procedures, are things that are going to organize our smart contract. I know this is an infamous example, but let's say you wanted to sort an array from minimum to maximum, or to do deleting deprecated entries in a voting array. People are voting for proposals. After a proposal is there for more than 1 year, I want to delete. These kind of housekeeping procedures inside the smart contract that are not critical, but are needed. For example, this is an ERC20 token. So let's say I want to have an array. I'm going to have a struct of a historic transfer that is going to have the address of the person, and it's going to have the uint 256 of the value. And I'm going to have an array of historic transfer public called historic transfers. I'm going to, instead of having all the historic transfers, I'm going to have the top 10 historic transfers. And how I'm going to implement this? A straightforward way is every time someone transfers, I update that array. That is something that requires a loop that is very heavy to do. So at every transaction, I'm going to burden the sender with this task of updating that array. Not always the sender wants to pay for that. The sender of the transaction just wants to send a transaction. But this housekeeping is needed. This is another thing that the automations can solve. Okay, the example here is not very important. Okay, it's just I have a structure of historic transfer, but I can track the sender and the value, and I'm going to keep an array of top 10 historic transfers. So how I would do that? I would keep an array of not tracked answers, answers that need to be sorted, and in time, or whenever this array has more than 10 positions, something like this, I could make a logic function to check for upkeep. Whenever this upkeep is needed, I can have a method to perform upkeep. Why is that important on chain? Why should I have the top 10 historic transfers on chain, for example? You could imagine some valid situations. For example, if you are the top 10 for more than 1 day or 1 year, you can claim an NFT. The person that has the high score of sender, the person that sends the biggest value can claim an NFT of trader of the day, of the week, or something like that. You could imagine situations that are on-chain that requires this upkeep to be performed, that are not just like visual, that are not just like things that you can do in the interface, are things that actually are going to have implications on chain. If I am inside this top 10, I can claim an NFT. So it's important to upkeep this on chain. But you don't want to burden your users with that. You want to keep it on chain, but you don't want to burden your users. So you can use an automation for setting up a network, a function that is going to trigger in the network to perform this upkeep for you. So you don't need to go there signing the transaction all the time. You can have this upkeep. You can even maintain a decentralized upkeep to make the community safe that this upkeep is not going to stop. Okay. Mitch, we are discussing the problem statement that Chainlink automation resolves. I'm explaining two situations that can complement or that can be alternatives where you want to use automations. When you have time-dependent logic that need to change the state in the future, and we've realized that this is not possible on-chain, and also when you need to perform some upkeeps that you don't want to burden your end user with that upkeep. Every time they send a transaction, you can have an automation to perform those upkeeps based on some conditions, time conditions or specific conditions, okay? We are in the first part, in the problem statement, in understanding the problem itself. Okay. Before we enter the solution itself, you see that this could be a manual process. I could be there doing those transactions myself, yes. But then I could someday become sick, not be able to do that transaction, or my wallet could be compromised, or I could have trust issues. This is a very central, a very centralization, a factor of centralization in my project. Okay, it is introducing a vector of attack as a central authority can perform this. So you can always keep those perform upkeep functions open for the end users to call themselves if you vanish, but also you can use the automation to grant that. Hey people, if I run away, if I die, or if I take a long vacation, if I lose my wallet, even though I do have this upkeep here to keep the project operational. Okay. Good. Is it a good way to keep a stablecoin peg? We're going to evaluate. Okay, I'm going to show you the tool, how it works, and then you can evaluate the use case. Could be useful depending, but also, for example, when the automation sends a transaction, they are not protecting this from front run, or they are not evaluating too much logic, unless you somehow this protection here into the logic function. We're going to see all of this, okay? Matheus solution, smart contract, emit event, catch event off chain, schedule transaction with event. Well, let's look at this picture, Matheus and Lucas. Sorry if I misspell your names. This is exactly what the Chainlink automation is going to do. Okay, instead of setting up it ourselves to deal with the setup cost, ongoing maintenance, risk associated with decentralized automation stack, instead of doing that all yourselves, running the server and blah, 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 we have this image here, this graph with this beautiful GIF doing that for us. The upkeep contract connected to your smart contract is going to check this upkeep time by time. Whenever you have a condition that meets this upkeep, that passes this logic function to check for the upkeep contract triggers that event. So you don't need to trigger the event yourself. And this event is going to be passed for an automation registry that makes the process more safe, that people are going to be there for answering, people are incentivized to answer. This upkeep is going to be taken care by the automated nodes. They initialize this upkeep procedure. When the check passes, the automation registry passes that forward. If the upkeep is not needed, it's going to just check again the next block. If it is needed, the automation registry is going to pass this forward and is going to call the upkeep contract call inside your contract. So you don't need to handle the event, you don't need to handle calling the upkeep. Chainlink handles all of that for you. You could imagine a line here exactly in the middle of this contract from the checking the condition and executing the condition. It's all taken care of by Chainlink. From defining the logic of the upkeep and defining the function method to do the upkeep, that is your job. See, they meet in the middle. This is exactly what this diagram is doing. Let me share the link. It is into the documentation. Okay, let me try and see that in full screen. Okay, I could have done that from the beginning. Sorry, didn't think on that. So quickly here, the automation nodes are going to be calling check upkeep again and again. Whenever you have a true condition here, this move false. If we have a false, we are going to be keep checking it block by block. If we meet the condition, this triggers the execution for the automation registry. The automation registry calls the upkeep contract with doing upkeep, and then do that into the blockchain. Okay. James, here we don't need the data to be accessible because the check upkeep function is going to be public. We're going to see that example. We're going to have this check upkeep public. Anyone can check to return false, 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 false. Then, oh, it's true. Then we call the method inside that contract for performing upkeep. Even if we don't dispatch the events ourselves, the network is going to be watching this in the check upkeep function. Okay. I'm going to explain like 20 minutes on that. We're going to do this together. Let's use the questions pane for piling up the questions so we can upvote and see what is more important for me to cover. And in chat here, I'm going to ask some more questions. Feel free to post in the chat as well, so we can pick up the speed here. Before we progress into implementation, can you see here already why we need the payment in link tokens? In the verifiable random functions, it's very straightforward to see as well, because we need to incentivize the network for being honest, for not lying about the randomness, right? Here, can you see the need as well? Whenever the automation node is calling check upkeep, that is a read function. It's not a problem about costs. But when it's performing upkeep, when it's executing this, they would need to pay gas, right? They would need to include this into the blockchain. So they would need to pay the execution cost for that. So we need to reimburse the automation node's execution for that with a little extra to compensate for their work, for paying the servers and the structure to work. Okay. So the first step we would need to do when we put our hands on it, when we start implementing, is exactly getting some link tokens, because we are going to need to incentivize the network to work for us. They're not going to work for free, unfortunately. Okay. So just like last lesson, we have some explanation here for the Chainlink automation, how it works. We're going to have two options here for checking the upkeep: a time-based trigger that checks by block or time by time. You have like an alarm clock inside Ethereum to govern this. You don't need to provide the logic for that if you're doing a time-based trigger. Is whenever you hit the trigger, you call the contract. The small problem with it is that you never know if a block is going to arrive before or after that trigger. Time-dependent logic is not so compatible with blockchain. Time-dependent logic could bear some problems. For example, if you are doing a stablecoin for pegging a stablecoin to a fiat money value, you could, with a time-based trigger, you could miss a block. You could have two blocks produced in the same interval, and then you have two blocks without updating that price. You see, or you could have the opposite, trying to update that in the same block, calling two updates. That would be a problem to coordinate as well. What if the second transaction gets included after? So this is, of course, if you don't control the nonce properly from those nodes, but you see that this could be a problem as well. Custom logic requires a little more of implementation, but it's more elaborated than just the time-based trigger. You could provide a function that the nodes are going to call and evaluate. Okay. The automation nodes evaluate this off-chain, like they have a local fork of the blockchain where they can evaluate that more quickly for gaining efficiency. So they calculate that off-chain in the local folks. They keep on forking on the blockchain, of course, to have this updated block by block. But then when they have a positive, okay, we should upkeep, and then they call that perform upkeep. For that, you need to comply to an interface, automation compatible interface, that is going to call the registry and is going to do all the work. Okay, I have a question here about the registry, and we're going to see it in action. Okay, there is a explanation here about the registry as well into the documentation, and it's basically the contract that orchestrate this process of doing the check upkeep and performing upkeep, payment of the link needed for that. This is one example of the tool that cannot be 100% executed just from inside the blockchain. We are going to see that we're going to interact with an automation UI later on. So this is another thing that the registry do is the coordination with the Chainlink automation application system with the smart contracts that we are going to plug in here to see if they have enough link to cover for the gas, the upkeeps, and all of that. Okay. I know it's too much information for little time. I'm just opening the subjects here. We are going to go over this slowly in the next minutes. Okay. Good. Some questions here into the chat as well. I guess I picked most. It is possible to get APIs to Chainlink. Okay, not here with what we are speaking today, but this is about the oracles. That is a workshop for those as well. It's like one of the main products of the Chainlink. Okay. So we are going to do these steps here. It's basically a copy of what is into the tutorial. So we are going to follow this tutorial up to this point. So we are going to have the smart contract just like we did last lesson, and we are going to interact with it. Before we jump into it, let's remember that we're going to need a link for this work. So if you want, let me pick the link faucet again. We should have it here into the README from last lesson. If you didn't attend to last lesson, that's not a problem. You can pick the link from, I'm quite sure I have this here somewhere. Here. You can pick testnet link from this faucet. You can, for example, if you're connected to Sefolia, you can pick this smart contract address and add to your MetaMask if you don't have this yet. You can add the custom token here to your tokens, to your assets, import token, and put the address of that smart contract here. Okay, I already have it into my tokens. I have 35.59 link here. If you need more links, you can get from this faucet. Okay, you can connect my wallet, verify that I am a human. Okay, that's a problem. I'm not a human. Just kidding, I am. Yes, I can pick those backpacks. Yes, I am a human. Just prove it for you. Oh, I fooled them. And then I can ask 20 testnet links here. To get a link on mainnet, you can ask nicely around. There are many ways to do that. But for today, we're just going to use on testnet, okay? For mainnet, this is like an ERC20 token that has all the token economics. For testnet, it's super easy. We can get it from this faucet and starting experimenting with it already. Okay. So I do have my balancing link here. You should have at least 10 or 15 tokens, or 20 if you ask from this faucet to start today's lesson. If that's a problem for you, just let me know. I could always send you some test link here. Testnet link, of course. Okay, once we do that, once we have enough link into our bags, we're going to move forward for those steps that we have into the tutorial. Okay, we are not going to assemble the contract ourselves. We are going to use this example, this provided example of a counter that we can easily open here in Remix, like we did last lesson as well. And this contract already takes care of those requirements. That is, importing the automation compatible .sol to have the automation compatible interface available for using. And when I implement my contract, for example, counter, inheriting from automation compatible interface, I'm going to have the possibilities. I'm going to have not the possibilities, I'm going to have the check, the insurance, the conformity check, that check upkeep and perform upkeep functions are exactly matching the definitions expected by Chainlink Automation Network. If I don't use the interface, I could miss in some parameters. We're going to see that the functions, for example, check upkeep should receive bytes, call data. Perform upkeep should receive bytes, call data as well. So if I don't include this, the function call could fail because the externally owned account calling it is not going to find the method ID, it's not going to find the proper signature, and this call is going to fail. Okay. So using the interface ensures that. And we also should have those two functions. Perform upkeep. It is 100% needed in our situation. This is what is going to be executed, the upkeep, the logic that is going to be handled. The check upkeep depends. If you are doing a time-dependent logic, check upkeep could be solved by calling this from time from the Oracle network, no, in this case, from the, how they call it? I just had it open into the introduction, into the automation nodes. So the automation nodes, if they have a check upkeep, this is going to be a custom logic, but if they have just a time-dependent logic, the automation nodes can determine that without asking your smart contract. After all, it's easy to determine time. Just look for a clock. Don't need to ask a smart contract for that. The check upkeep can use on-chain data to receive parameters, you determine what is going to do. If it is like you mentioned here in the chat, pegging a stablecoin, this could consume from an oracle, this could consume from a history of trades, calculate an average and all of that, and can use bytes passed for this call into the check data as well. We're going to see that not here, but here, we're going to see that we can receive a call data here when we when we do this operation, and we are going to be able to specify this when registering the upkeep later on as well. Okay. Let's see if we have questions. Just Gregory, that question on the registry, no comments. Okay. So those are the requirements for me to integrate this into the automations network. So let's give a look in this example contract, this counter that we have here. Inside the constructor, we are defining some specific logic here for the things we want to do inside that contract. And this is different from the VRF because I don't need to specify the address of the contract that's going to behave like a VRF Oracle or blah, blah, blah. Why? Let me keep this GIF open. Okay, this is going to be super helpful. Because the automation node is going to start the process. You could protect your contract from all the people calling, but in this situation here, this is not needed. So in the constructor, I don't need to set up any address at all. Hey, watch out, you're going to be called from that address. This is not a need here for this contract. I could have anyone calling this upkeep function. Okay. Remember that example with the top 10? This could be similar. I have a check upkeep. Let me fold this implementation. Let me fold this implementation. And this is usually how you implement automations. You just like the to-do we had a while ago. We have one function to determine if the upkeep should be called or not, and another function to perform it. If we were expecting a super complex design on assembly code and blah, 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 sorry to disappoint you. This is just two functions that combined can work with the automation network with the automation nodes. Okay. Okay, let me give a look on those comments here. Using an Oracle automations for keeping stablecoins, yes, you wouldn't be able to protect again against Mav bots or such. Okay, that is a threat. Okay, good questions here. Yes, I'm going to cover those reversions situations later on, because one of the things is when they say this here, let me see where they state this clearly. The perform upkeep here, if that is going to revert, if we have a reversion situation here from perform upkeep, this is a delicate scenario, because you have paid for that transaction. We're going to see how we supply this feed later on. And this check upkeep is not by default retrying, because retrying is not a solved thing for the thing. You could retry in the next block, and then you lost the opportunity for performing that upkeep in the previous block. So there is a possibility for revalidation of perform upkeep. You need to design this. We're going to speak about those best practices after we go through the getting started, after we go through the step-by-step, so we have a more basic understanding before we get there. Okay, we still have 15 minutes or so. It's going to be enough time. Okay, the structure is good. If you want to implement your own contract here, my contract, you can implement any kind of logic that you want, so long you have this check upkeep to return a boolean if the upkeep is needed or not. This is the only condition. And then a perform upkeep that need to be called later on to do that upkeep. Okay. Good. So what is the implementation example that we have from this counter? It is time dependent logic as well, just as a mock, just as an example. So here we have a determination if the upkeep is needed or not by checking if the block timestamp has passed for that interval. We have the last timestamp of the last upkeep triggers, and the block timestamp is always increasing, block by block. Every time the network receives a new block, this timestamp increases. Once it is higher than interval, this check upkeep could pass. You can pick any logic here. Lines 41 and 42 are open for you for editing. You can provide this up, you can return true for this check upkeep whenever you have a balance after a threshold, whenever you have a number of entries in an array, whenever you have a random conditions, whenever you have an oracle condition, whenever you have a block number that is odd. Let's say you are minting an NFT. Whenever the block number is odd, you have a sad face. When it's even, you have a good face. So you want to perform an upkeep of the NFT images block by block. Gas intensive, I know, but just follow the idea. You could have NFT smiling, then NFT sad. NFT smiling, sad, based on any kind of logic you want to put here. Odd or even, divided by 10, balance. You can put any kind of logic here. Solange is a very good example when I explain about this into the generative NFTs, how they change over time. You can make NFTs images change over time by changing the metadata. And this is one of the things you can perform an upkeep to. So lines 41 and 42 are a blank canvas. You can paint anything your creativity wants here. In the perform upkeep is where you do the actual work of changing whatever you want to change. In this situation, we are keeping track of a state variable called counter. It's a number that starts at 0. The default here is 0. This line 30 is completely useless. It's not needed. It's writing 0/0. And then we have the timestamp check here, increasing the counter plus 1, 1, 1, 1, 1, 1, 1, 1. And then we have the block timestamp set by the last timestamp here. Okay. It is good to revalidate the logic for the upkeep function. Just mentioned that in the good practice, because in this perform upkeep, in this situation, anyone can call this. So if I don't include this if block to revalidate the condition, people could call perform upkeep directly and force the counter to increase. It is good to keep the perform upkeep function open because you can protect the community if the automation network stops. If you run out of funds on that automation network, anyone can go and call the perform upkeep manually. Okay, so it is good to be there, but if you don't revalidate the upkeep, you could have a big problem here. So lines 47 to 50 are up to you to change, but I heavily recommend you for keeping this line 47 and 50, not exactly the same logic, but you should evaluate what you are doing here into the upkeep needed. Then you replicate and revalidate this here. Okay. Reducing the, okay, there is no way to reduce the explorer, unfortunately, just off, on or off, but I guess this is better. Good, let me see any other questions. Okay. So what is good for changing? The logic inside upkeep, the logic inside check upkeep, yes, the logic inside perform upkeep. Remember to revalidate the check upkeep inside the perform upkeep just for protecting from people calling it directly. The function perform upkeep is for updating anything. I used 2 examples into the problem statement early on. The example of an array in the top 10 and the example of an unpause. It should unpause after some amount of time. So those are 2 not entirely token related. Could be applied for token, but could be applied for any other situation, for a game, for example. Okay. This structure is clear for all of you. I should have check upkeep, then perform upkeep. They are going to determine this flow chart if if the condition is met or not, and is going to determine what is going to be triggered when we call the upkeep contract. Okay. Now we put our hands on executing that. We're going to open this contract in Remix like we did, compile and deploy, okay, with some conditions. And after we deploy, we are going to use this application automation UI to set up this this automation logic, the system that is going to be calling this over and over from Chainlink side, from the Chainlink structure. So to do that, I can compile this automation counter just like we did on previous lessons. I'm going to connect to an injected provider. MetaMask here is already connected to Remix. And I'm going to deploy this counter contract with an update interval number. This update interval is going to determine how much should I wait for each next upkeep that I'm going to do. They suggest us to pick 60 seconds. That is good enough for us to see some good upkeeps, some good handful upkeeps within this lesson, in the next minutes. So I passed those 60 seconds as parameter, and then I'm going to confirm for deploying this to the Sepolia testnet. Okay, Once we have this contract deployed, we have the counter deployed, we have it on chain, and it is not doing anything on its own. I can call perform upkeep directly, you see? I am able to call that. I can call check upkeep directly, just passing 0x bytes here. The upkeep needed is false at the moment. Okay, can go calling it again and again. And I could call perform upkeep, but remember, I don't want to have the burden of this doing myself. I don't want the user to have that burden, and I don't want to automate this myself as well. So what I'm going to do, I'm going to hire the services from the automation network to register this new upkeep for me. Okay, so this is the last step here. Third step, you go for automation UI for this link, and you follow this simple steps. I'm going to connect my wallet, MetaMask wallet. Okay, this is entirely for the this is going to be operated in the other side by Chainlink. Okay, so it's entirely a relationship between the user and Chainlink. This is not possible to be done on chain at the moment, as far as I know. So you need to use this application for setting it up. So we are going to do a custom logic. I know it's time dependent, yes, but we are going to check the check upkeep function to do this custom logic. And we should put the address of the target contract here into that form, so that the Chainlink is going to call the check upkeep. They have already validated that this is an automation compatible contract. The functions are there. Chainlink is going to call that contract address from time to time, and I can manage this upkeep with them later on with those parameters. Okay, let's fill this form, upkeep details. So this is going to be my test upkeep. So that's the address of the administration of the upkeep. It's going to be my address, my wallet address here. Could put another person as administrator. I'm going to give a starting link balance. For example, I'm going to give one link starting on that. And I can even have hexadecimal data here, optional, of course, but I can even pass this hexadecimal data to do some validity check, to do some possible conversion to bytes for passing some parameters, for checking this static data for the check upkeep function. Okay, everyone can see that data. They can even do an upfront run on you, front run you, if you use this data for something that is private. For example, let's check if the data is correct. This is vulnerable for front running. Okay, so this is more like for a static data, static constant that you want to pass. You could have a lot of different designs here. Okay, you can give your email and name if you want, optional. That's not needed. So let's register this upkeep. Now, again, can you see Gregory, the registry? This is going to submit a registration request. I'm going to confirm this here into MetaMask. This is going to send a transaction for the network. I need to confirm that on chain with the link that I have transferred. Okay. And once this is deployed, this is going to be funded with enough link to pay for the executions of all of those upkeep calls, upkeep transactions to execute this. Okay. Some Apache Kafka vibes. This is how we are going to see this dashboard. Okay, Matheus? We're going to orchestrate the keepers from here as well. We can delete, we can pause them, we can withdraw money from them. This transaction is taking a while. And Rodrigo, this check data can be used for calling those all the smart contract. You can pass an address, you can pass a number, you can pass whatever data you want, a boolean, whatever data you want. Okay. So this was deployed. Okay, I have this contract here for the registry updated here with the money with the link token. I transferred this one link there for funding these executions. And where is my upkeep here? Okay, it's red. What happened? Unexpected JSON, but what happened? Okay, I have this upkeep here, test upkeep active. Okay, with the balance of one link. I don't know, let's see. The application is a little slow, but this is the dashboard you mentioned, perhaps, Matthias. We're going to be able to see. We should be able to see. Okay, these kind of things happen, but we should be able to see in that dashboard. Here, see, I didn't break it. This upkeep, it is currently underfunded. Let's see if the transaction didn't confirm yet, but there is a action here for funding this upkeep as well. I'm quite sure I've sent one link to it, but we can always send again one link. It's not going to hurt. Or perhaps they didn't update, but I can send one more link to it. The worst case scenario is going to have two links. And this is going to consume a little more of link every time that they perform an upkeep, depending on the gas cost on the upkeep being performed on the transaction. Okay. So what is going to happen? Let me answer that question for you, Leonardo. It is exactly this GIF. Okay. It is going to check upkeep time by time, block by block, and this is not going to pass frequently. No, this check upkeep is just going to pass sometimes. And when we call perform upkeep, this is going to actually change this counter. Okay, the counter currently is at 1, so the upkeep was triggered. It started on 0. Okay, and the last timestamp of the upkeep is here. The upkeep was performed. And if we wait for 1 more minute, we are going to see this counter increasing for 2. We should be able to see this upkeep here into this dashboard. Here, it ran. Okay, so the upkeep is running. They are calling these functions. They are spending a lot of link here, it seems. Oh my God, but that's okay. It's going to drain quickly, but it's going to be able to call this upkeep a few times. This is being checked into the automation node, checking again and again and again and again to see if an upkeep is needed. I don't need to do anything else. I just wait. I can take a vacation. I can go sleep. This upkeep is going to happen even if I don't interact with it. I just need to remember to eventually drop some link here for the balance of that registry for it to be able to be paying those transactions, compensating, reimbursing the cost of the transactions for all of those nodes operating these upkeeps. Okay, so we can see the counter increasing. Okay, my contract froze here. I need to connect again to MetaMask. Let me attach, and I can see the counter here increase it to 2. Timestamp increase it as well. See? So it is working. It is able to update the counter here. It is, even if we don't interact with the contract, this counter is going to keep increasing for the next hours and for next minutes if the link balance is enough, and we don't need to handle this ourselves. Okay, I guess this is it. We are on time, but I hope you have enjoyed. Feel free to reach me in all of those channels. create GitHub issues, ask questions, and let's build great things with those tools. Thank you, everyone.
Thank you so much for attending, everyone. I believe that the next session will be, is it next Thursday? It is next Thursday. If that is not the case, I'll send an email update. But in the meantime, have a lovely rest of your evening or wherever you are in the world. Bye, guys.